Welcome guys back again to another video. So in this video we are going to talk about the next step of our retrosynthesis analysis. Okay, now this is our fourth video of our playlist about retrosynthesis analysis. If you have not watched our previous videos, I highly recommend you to go back and watch them, because if you are new to this channel, if you are new to this particular topic, then you need the basics. So I highly recommend you to come from the beginning, then it would be fine. But otherwise, like, if you are okay with it, if you have learned this and if you just wanted to quickly memorize this stuff, then it's fine, you can stick with this straightly. So let's talk about this video. We are going to talk about the alpha beta unsaturated structures. Okay, we are going to see how these alpha beta unsaturated structures, how we can introduce a retrosynthesis analysis for these particular molecules, right? Basically, the alpha beta unsaturated structures means these guys. Let's say we have our group here, and here we have a carbonyl group. Let's put another R2. You know, this is the carbonyl group and this is the alpha carbon and this is the beta carbon. Alpha beta unsaturated system means here you have a double bond between the alpha and beta carbons. This is the alpha beta unsaturated structure. Now, if you have this shape in your target molecule, right? Let's take an example. You are asked to propose a retrosynthesis analysis for this particular molecule. We have a benzene ring here, and we have double bond here, and we have a aldehyde here. Now you are asked to propose a retrosynthesis mechanism or retrosynthesis approach to this particular target molecule, right? Now what you can do is, first you have to identify the pattern, right? There are specific patterns in our molecules. So based on these patterns, we are going either way in this retrosynthesis analysis. You can say this is an alpha beta unsaturated system. This is the carbonyl group alpha beta. Alpha beta is unsaturated, then you have this structure. Then what you have to do is, first you can change this functional group. Let's do a functional group interconversion. If you are new to this term, functional group interconversion, we have talked about in our previous two videos, right? So you need to memorize it, like you need to get the idea about functional group interconversions. After that you are going to be fine. It's not a big deal, right? It's a very small video, like around 5 minutes. Let's move on. Here what we are going to do is, we are going to introduce a OH group to our beta carbon. Okay, we are going to introduce a OH group here to this carbon. Now you may think, like, why do we have to introduce the OH group into this particular beta carbon? Why can't we do it on the alpha carbon? Yes, you can, right? You can do it, but when it comes to this alpha OH group with this carbonyl group, it's a little bit getting destabilized, right? It's a little bit unstable than this. This is much more stable than the OH group on here. So it's better to go with the stabilized one. So otherwise you will get a destabilized product. Always remember, we are going in the reverse direction, right? We are going this reverse direction. So you need the stabilized products in order to, like, you need to stabilize reagents here. These are the reagents. So you need to go from here to here. So I hope you are fine with it. So you have to do the functional group interconversion with OH attaching to this particular position. Now what you can do is, we can do a disconnection through this bond. So I have done a mistake. This should be a double arrow like this. Now we have two synthons. We have the thing with benzene structure. We have the OH with the positive charge. If you remember from our previous videos, we have talked about this. If you have disconnected with this, like the carbon containing OH group, this has to go with the positive charge, because you have a oxygen here. You can form the resonance structures to stabilize this. And here we have the oxygen and hydrogen. We have the negative charge here. Now you need to introduce the synthetic equivalence. I hope you know what the synthetic equivalence for this is. It's pretty much easy. We have talked about in a lot of examples. It should be an aldehyde. Okay, here we have the aldehyde here. This is the synthetic equivalence. What is the synthetic equivalence for this? It's the same, right? Just ignore the lone pair. If you remember, like if you get the idea, right? This is a nucleophile, right? This is a nucleophile. So you can see this is a carbonyl group and this is a alpha carbon. This has a relatively high acidity. So with a very good, like not a good, like if you can introduce a basic medium to remove this one of the hydrogens and create a lone pair. Now you can see this is lone pair. There's a lone pair. There's a carbonyl carbon. You can easily go and attack to this with aldol condensation. With aldol condensation, you can achieve this OH group and then easily removing the OH group to form the double bond. That's the case. So let's move. This is the retrosynthesis analysis, right? This is the retrosynthesis analysis. Now let's look at the synthesis process. Okay. Now in the synthesis, you can see these are the two reagents which we have, benzaldehyde and this guy. Now what you have to do is you need to add both of these things. Let's add this in the presence of this one. Okay, this should be a basic medium, right? This would be a basic medium. So you can add any basic medium. You will have the product of this one, basic medium, and then you need to add the acid to obtain a hydrogen here. So let me okay, now it's fine. Now you can remove the OH group alongside a hydrogen. You can add concrete H2SO4 and put the reaction. Concrete H2SO4, which will remove the H2O molecule, this OH and one of the hydrogens here. Here you have the target molecule. So this is the alpha beta unsaturated structure. If you have that structure, you can easily follow these steps to introduce a retrosynthesis analysis. I hope it's fine. It's not that big deal. Like you need to do the questions. That's how you can do it. Like we will do the questions after some few videos, and when we are going deep inside this retrosynthesis analysis, then you will get the idea how to use it when it comes to questions. Okay, if you have any questions regarding this particular structure and this particular procedure about this alpha beta unsaturated systems, please feel free to comment below and I will try my best to help you. And let's look at another one example. Okay, how about this guy? How about this one? How we can introduce a retrosynthesis analysis for this particular target molecule. Now you know, first one, what we have to do is functional group interconversion. So I hope like you have to pause the video and try it out yourself, right? That's the best way to learn these mechanisms. Okay, now first thing what we have to do is functional group interconversion. You need to introduce the OH groups in order to break this alpha beta unsaturated system. You can see this is the alpha beta unsaturated system, alpha and beta. So first you need to introduce the OH group. To which carbon you have to introduce the OH group? To either O here. You need to be able to answer that question. It should be here, right? Because this is not going to be stable because you have a carbonyl group adjacent to each other. So it's not a very good method. So you have to introduce a OH group to this position. Let's introduce one. Here we have the OH. Now you can do the disconnection here. You will achieve two synthons with the positive charge here. You know this, when there's a carbon attached to a OH group, it should contain the positive charge. With the other synthon is here. With a negative charge. Now you know how to introduce the synthetic equivalence. This is the OH group alongside. So what you have to do is introducing a carbonyl group. Okay. and then in other case what you have to do is just ignore the lone pair, because you know this is alpha carbon. This hydrogen which has in this carbon contains a acidic properties, so you can easily remove one proton by introducing a basic medium. So this is just a molecule we have. So these are the synthetic equivalents. So basically the same thing, like just like here. Sorry. Here. Just like here, you just need to add these two guys. So the aldol condensation will be placed here. Then you need to remove the OH and one of the hydrogens here to obtain the final target molecule. So this is the retrosynthesis analysis for alpha beta unsaturated carbons. I hope you okay with it. Like this is the most important structure, like most important shape of our retrosynthesis analysis. You will find lot of molecules with the alpha beta unsaturated systems. Let's do some questions in our next few videos with the ring structures, like the cyclic compounds. So that's where the things get a little bit tricky. So in next videos, probably this is the 4th video, and probably in the 6th videos we will introduce to the cyclic compounds. So I hope you're okay with it. In next video we will talk about the 1,3 dicarbonyl compounds, and if you have a question, feel free to comment below.